How do you use steam tables for non-ideal gas properties? Imagine trying to figure out the exact behavior of steam in a power plant or a heating system. It's not as simple as using the ideal gas law because steam often behaves differently, especially near phase changes. That's where steam tables come into play. They are like a detailed map that shows the properties of water and steam at different conditions. These tables give us real data for pressure, temperature, specific volume, enthalpy, and entropy, which are all important for understanding how steam behaves in various states. To use these tables for non-ideal gas properties, you first need to know the current state of the water or steam. Is it in a liquid state, a mixture of liquid and vapor, or a fully vaporized state? This depends on the pressure and temperature you are working with. If the pressure and temperature are close to the saturation point, you are dealing with saturated steam or water. If the temperature is higher than the saturation temperature at that pressure, then you are in the superheated steam region. If the temperature is lower, then you are working with compressed or subcooled water. Once you identify the state, you select the correct table. For saturated steam, you use the saturated steam tables. These tables list properties at the saturation temperature and pressure where liquid and vapor coexist. For steam that is hotter than the saturation point, you turn to the superheated steam tables. If you are dealing with water below its saturation temperature at a given pressure, then the compressed liquid tables are your go-to. Next, find the closest pressure or temperature value in the table to what you know. If your exact value isn't listed, don't worry. You can interpolate between two values. For example, if you need the enthalpy at 320 degrees Celsius but the table only shows 311 degrees Celsius and 350 degrees Celsius, you estimate the property by drawing a straight line between these 2 points. This interpolation gives you a more accurate estimate of the property at your specific condition. After locating or interpolating the data, read off the values for specific volume, enthalpy, internal energy, and entropy. These numbers are what you will use in your calculations. For example, if you are analyzing a thermodynamic cycle, these properties help you determine work done, heat transfer, and efficiency. Using steam tables instead of ideal gas laws is especially important near phase changes because real steam does not follow the ideal gas law perfectly. The tables account for molecular interactions and phase behavior, making your calculations more reliable. They are essential tools for engineers working on power plants, heating systems, or any process involving water and steam. In summary, to handle non-ideal gas properties with steam tables, you identify the phase, choose the right table, find or interpolate the data, and then apply those properties to your calculations. This process makes understanding and working with steam much easier and more accurate, especially when dealing with real-world systems.